In this video, we're going to talk about how to find the determinant of a square matrix regardless of its dimension. So that means we can find the determinant of a 5 by 5 matrix or a 12 by 12 matrix. And it's not as hard or as tedious as you think it might be. I want to start by finding the determinant of this 3 by 3 matrix. This is the same matrix as we were looking at on the previous screen in the previous video. So let's find the determinant of this matrix using the technique that we already know. And that means that we're going to take, let's do this. The determinant of C is equal to, and we're going to have the first column, first row entry, which is 1, and we're going to multiply that by the determinant of this submatrix. And that is 0 minus 1 times negative 2. To that, we're going to subtract, or from that, we're going to subtract the first row second column times the determinant of, I guess I'll go ahead and use a highlighter for these two. First row second column times the determinant of the submatrix formed from these 4 entries. So that's going to be negative 1 times 0 minus negative 2 times negative 2. And finally, we'll add, I'll use blue, first row third column times the determinant of the matrix formed by these 4 entries. So we'll get 0 times negative 1 times 1 minus 0 times negative 2. And obviously this whole term is going to be 0 because of this 0 factor here, but that's okay. I'm doing this to make a point. We know how to find a determinant of a 3 by 3 matrix already, but I'm doing this to make a point. So if you'll bear with me while I work this one through, then after I'm done, I'm going to show you something that's really quite useful. All right, doing this computation, I get 1 times 2 minus 2 times negative 4 plus 0. That's going to give me 2 plus 8 or 10. So the determinant of that matrix is 10. Now, the thing that's really cool about knowing how to find a cofactor is that we have other ways of finding this determinant. We're not restricted to only using the first row as our coefficients. When I say coefficients, I really mean these numbers here. I can actually use any row I want. So I'm going to take the same matrix, matrix C, and I'm going to find its determinant again, but this time I'm going to use row 2 for my coefficients. So let's see, I'll use the same colors here. I'm going to use this as my first coefficient, negative 1, and I'll use this 0 here for my second coefficient, and let's see, I used blue for my third one. That's going to be negative 2 for my third one. So my coefficients this time are negative 1, 0, and negative 2, and I'm going to multiply those by the determinants of what's left over when I cross out for the negative 1, when I cross out row 2 with column 1. The 0 will be row 2 with column 2, and row 2 with column 3. Gives me the negative 2, and the determinant of what's left over. So to find the determinant of, sorry, I lost my pointer. To define the determinant that goes here, I'm going to cross out row 2 and column 1, and that leaves me with a determinant that's made up of these 4 entries, 2, 0, and 1, 0. And if I take that determinant, I get 2 times 0 minus 0 times 1, and that is 0. And then for my next determinant, I'm going to have 0 times, what happens when I cross out row 2, column 2? I'm left with a matrix made of these 4 elements. My determinant then is 1 times 0 minus 0 times negative 2, and that is also 0. Lastly, I'm going to cross out row 2 and column 3. That's how I get this coefficient. It's the thing that gets crossed out in both of those. And what's left is this submatrix, and the determinant of that submatrix is 1 times 1 minus 1 times 1 minus 2 times negative 2, which is negative 4. All right, now I've left something out, kind of done it on purpose, but I'm going to go back and do it now. Remember that since we're dealing with the second row here, if I superimpose a sign array on top of this, I'll get positive, negative, positive, negative, positive, negative, positive, negative, positive. And since I'm working with row 2 here, I need to make the signs of my coefficients match not the coefficient sign, but I need to apply this sign to my coefficient. So that's going to make this a positive 1. Actually, I think what I'll do is I'll put a negative out in front of that. I'll put a positive out in front of this one. Turns out it doesn't matter because it's 0 times some stuff, and 0 times anything is 0. Now this one needs to have a negative in front of it. It already has a negative in front of it. That's because this number, this entry, is negative. I need to make the sign in front of that also negative. The other way we can arrive at these signs, remember, is that for this one here, I'm going to take negative 1, and I'm going to raise it to the power. This sign right here is going to be negative 1 raised to the power. The power comes from adding together the subscripts that come from this entry. So this is row 2, column 1. So this is going to have a subscript of 2, 1. So I'm going to add together 2 plus 1. The next one has an entry of row 2, column 2. So that would be entry A, 2, 2. And so I'm going to have an exponent here of 2 plus 2. And the last one is row 2, column 3. So that's going to be 2 plus 3. And you can see then that this is 3. 2 plus 1 is 3. Negative 1 to the third power is negative 1. So this term in my expression here gets negated, right? Whatever sign this is, we're going to end up changing it. This is an even number. 2 plus 2 is even. Negative 1 to an even power is positive, and negative 1 to an odd power is negative. So that's the other way we can do these. All right, this gives me 1 times 0 plus 0 times 0. It's not looking good, but hang on, because now I have plus 2 times 1 minus negative 4 is 1 plus 4. That's 5, and that gives me 10, which is what I had up here. What is perhaps even more interesting is that you're not restricted to using rows for your coefficients. Let's do this one more time. I didn't write in here that what I was doing was finding the determinant of C. And I'm going to do that again here. The determinant of C is equal to, I'm going to have a sign, a coefficient, and a determinant. A sign plus or minus a coefficient and a determinant, and a sign, a coefficient, and a determinant. But this time, I'm going to use column 3. So the coefficients then are 0, negative 2, and 0. The signs I will borrow from the version of the matrix. I already superimposed my signs on this one, so I'm going to have a positive, a negative, and a positive. I don't really need to write a positive here, but I will. A positive, a negative, and a positive. And then just to alleviate any potential confusion, I'm going to get rid of this blank line that I drew here so we know what's really going on. And then my determinants, these determinants are found the same way. And remember that those are called the minors of an entry. So the minor of this entry, it doesn't really matter. This term's going to be 0, and so is this one, right? But I'm going to do this anyway just because I want you to see. I want a little bit extra practice here, figuring out what these numbers mean and where they come from. So the minor associated with this entry here is this entry is in row 1, column 3. So if I cross out row 1 and I cross out row 3, that's the entry that gets crossed out both in the row and the column. So that goes there. But what's left is this submatrix here. And the determinant of that submatrix is called the minor. So I'm going to take that determinant. I get negative 1 times 1 minus 0 times negative 2. So it's just minus 0. And then I'll do the same thing for here. This entry right here, this value right here comes from this entry. It's the number that gets crossed out when I cross out both gets crossed out twice, when I cross out both row 2 and column 3, right? So that's where that number comes from. What's left when I do that is a submatrix made of these four entries, 1, 2, -2, and 1. And the determinant of that submatrix, the minor of -2, the -2 in position 2, 3, is a 1 times 1 minus 2 times -2, or -4. And then our last one, again, it doesn't matter because this is a 0 that's going to be multiplied by anything. That's going to give us 0. But just for practice, this is the entry. It's in position 3, 3. It's in row 3, column 3. That's the one that gets crossed out when you cross out row 3 and column 3 is 0. What's left is this submatrix. The determinant of that is the minor of this 0. And that value is 1 times 0 minus 2 times -1. And we're going to get 0 here, we're going to get 0 here, and here we get positive 2 times 1 minus -4, which is 5, and that again gives us 10. So it doesn't matter which column or which row you use for your coefficients. Finding the minors, the determinants of the submatrices that are left over, and then finding the signs. Once you have all that correct, it doesn't matter which row or which column you choose for your coefficients. Okay, now, this is very powerful because there are times when it's going to be super easy to find a determinant using one row when it might be very difficult to find it using a different row. And equally, now that we have a system for doing this, we're going to be able to take the determinants of much larger matrices. We're going to look at that next, but before we do, I just want to clarify, I just want to put a label on this, if you will. What we've just done here by finding the cofactors, that is these numbers here, sorry, these are the minors, right? And then we found the cofactors by applying the appropriate sign to those minors, right? What we've done is called cofactor expansion. We've expanded, oh, I don't know, an expression. I'm not actually sure where the word expansion comes from, but that's what this process is called, cofactor expansion. We've expanded this column in this case, second row in this case, multiplying it by the minors and then assigning the appropriate signs to multiply each of these by its cofactor. And we've used this cofactor expansion, we've used that to find the determinant. We've done it with 3 different sort of approaches. Here we used row 1, here we used row 2, and here we used column 3 for our coefficients. So this process is called cofactor expansion, and now that you know that vocabulary, you'll see it quite a bit. What we're going to talk about next, though, is how to use this to find the determinant of a much larger matrix. If I wanted to find the determinant of this matrix, let's call this one D, then remember I can use any row and any column that I want as my row for my coefficients. And so I'm going to start by using this row here because it's got quite a few zeros in it. It's got 2 zeros in it, which makes the work of finding the minors really quite simple. I mean, I don't need to find the minors, I guess is my point. The determinant of D is going to be, in this case, A21, the entry in row 2, column 1, right? It's going to be A21 times the cofactor of 21, the cofactor of entry 21, right? This is the entry. Sorry, I used my eraser instead of my pointer there. This is the entry 2, comma 1, row 2, column 1. So the coefficient is 1. It just comes from that entry. And then I need the cofactor of that entry, which is equal to, there's more here. This is equal to 1 times -1 to the power 2 plus 1 times the minor of 2, 1. Remember, the minor is just the determinant of the stuff that's left over. If I cross out both row 2 and column 1, then that minor is just the determinant of 1, 3, 0, 2, 1, 0, 3, 0, 1. Okay, so I'm going to stop and back up and write this out now, but by way of reminder, each of the terms in here is made up of, first, the coefficient coming from the chosen row times the cofactor, and the cofactor is just the minor, which is a determinant, plus a sign, plus or minus, right? Positive or negative. So let me erase a little bit of this here now. I'll write this out as the sum of the cofactor, the coefficient, times the cofactor, this one's going to be row 2, column 2, plus the coefficient times the cofactor, row 2, column 3, plus the coefficient times the cofactor, row 2, column 4. Now, I've written these all as plus because the cofactor is either positive or negative depending on these subscripts, right? This one's going to be negative because these two numbers, these two digits add up to an odd number. So that's going to be negative 1 to the power of 3, which is negative. This one will be positive, negative, positive. Okay? Now, the neat thing here is that this one is going to be 0, and this one is going to be 0 because 0 times, this cofactor here is just a number. It might be positive, it might be negative, but 0 times that number is going to be 0. So this is really equal to 1 times the cofactor of entry 2, 1, plus 1 times the cofactor of entry 2, 3. I only need to work out 2 of those sub-matrices determinants in order to do this problem. I don't need to work out all 4 of them. All right, let's figure out what those are. Cofactor 2, 2 is going to have a sign associated with negative 1 to the power of 2, 2. And then we're going to find the minor 2, 2. And then we'll add to that negative 1 to the power of 2 plus 3 times the minor of entry 2, 3. Well, negative 1 to any even power is positive. And so I have 1 times the minor of 2, 2. Negative 1 to an odd power is negative, so I'm going to have minus the minor of 2, 3. So far all I've done is figure out what my signs are, and I've got my coefficients in place. This one was 1 and this one was 1. That comes from here and here. And I've determined that I don't need to work these ones out at all because these coefficients of 0 are going to make those terms go away anyway. So now all that's left to do is figure out what those 2 minors are. My signs are in place. My coefficients are already in place. I don't really even need to write that 1, but I'll go ahead and do that I'll leave that there. The minor of 2, 2, the minor of the entry from row 2, column 2, is the determinant. Let me use a different color. The determinant of the matrix that's made up of the entries that are left over when you cross out row 2 and column 2. And those are 2, 3, 0, 2, 1, 0, and 2, 0, 1. Did I get those right? 2, 3, 0, 2, 1, 0, and 2, 0, 1. Right. And from that, I'm going to subtract 1 times. Now this time I'm going to cross out row 2. Use a different color. Row 2 and column 3. So anything that's not highlighted in blue now gets put into my matrix so I can determine its determinant. I get 2, 1, 0, 2, 2, 0, and 2, 3, 1. Okay. Now, if you can imagine working out, let's take a look at, I don't have any row here that doesn't have at least 1 0 in it, but let's imagine for the moment that we decided to use the first row for our cofactor expansion. I would have to work out the determinant of this 3 by 3 matrix, and then the determinant of the matrix made up of these 3 entries and these 6 here, and then the determinant of the matrix made up of these 2 columns in this row, and then I've got a 0, so I can let that one go. But that's going to be some tedious work. Because I've got 2 zeros in this row, I only have to work out 2 of these values. Both of those values include working out a 3 by 3 determinant, but I'm going to use the same trick again. I'm going to make the observation that I have a row here that has a 0 in it, and I could have used the second row as well, I suppose, there. and relatively small numbers. I'm going to use row 1 here for this one. And that gives me 1 times, now I'm using a 3 by 3 matrix, so I have this sign array. And I'm working with column 1, row 3, so that's positive. So I'm starting with a positive. I'm going to rewrite this slightly because I want to clarify something. This is going to be equal to 1 times, I don't want to use 1 times a determinant, which turns out to be a value, right? That turns out to be a number. All right, giving myself some space. This -1 goes here. The determinant of this matrix is going to go here. This one's going to go here. All right, so when I figure out, in order to figure out what this determinant is, I'm going to, starting with this entry, I'm going to write out my coefficients, 2, 0, and 1, and I don't need the 0. I'm going to observe my signs are going to be positive, negative, and positive. This is positive, negative, and positive, but I left out the 0 because what happens when I have a 0 as a coefficient is the whole term goes away, right? So I don't need to work out the value for the submatrix determinant for this this coefficient. And then I need to take the determinant, this turned out to be a plus, of the matrices that are left over. With the 2, I'm crossing out the row and the column that the 2 is in, and I'm left with this matrix right here. Well, look at that. That's 3 times 0 minus 1 times 0. That's 0. Boom. I'm actually going to erase my determinant sign, my vertical bars, because they're not really necessary. And then for the second one, the 1 comes from here. So I've crossed out the 1 by crossing out both the third row and the third column. I'm left with this submatrix here. So the minor here is 2 times 1, which is 2, minus 6. 2 minus 6 is -4. And I'll do the same thing for the second matrix. Second 3 by 3 determinant. I have 2, and I have a 1, and I have a 0 up here, so I'm going to have a plus 0 at the end. My signs, I have a 3 by 3 matrix. My signs are going to come from the first row, so I have plus minus plus, positive 2 times the determinant, plus 1 times the determinant, it's a minus this time. We're going too fast. My 0 is the last term there, so it's it would have been positive, but it's times 0, so I don't need to even write it in there. Okay, so now I'm going to find the determinant that's going to go here. I have 2 times the determinant of 2 times the determinant. The determinant comes from the matrix that's left over when I cross out the first row and the first column. So 2 times 1 minus 0, so that's a 2. And then this 1, if I cross out the first row, second column, I get 2 times 1 minus 0, so I get a 2 there. And that really wasn't too bad. I mean, you have to think carefully about what you're writing down and where, and make sure your signs are correct. But it wasn't nearly as tedious as it seemed like it could potentially be. To finish this off, I have 1 times 0 minus 4 minus 1 times 4 minus 2, which is -4. That's going to be 4 minus 2 is 2, and I have a -1 times that, so it's -2, so I get -6. My determinant, the determinant of this 4 by 4 matrix is -6. Now, I'm going to do this problem again because there's an even shorter way to do this. Okay, here's that same matrix again. What I'd like to observe this time, remember from the previous video when we said that you could use either a row or a column? Well, look at this column. It's almost all zeros. So why don't we use that one for our cofactor expansion? The determinant of the matrix D is equal to 0 times something, 0 times something, 0 times something, and then 1 times something. And that something is a determinant. It's a minor. We can compute that minor. We'll come back to that in a minute. Let's take a quick look at the values of the signs in front of each of these terms. It doesn't matter for the first three, but it will for the last one. So for practice, this entry, which is where this first coefficient comes from, this entry is in row 1, column 4. So this value right here is going to be cofactor 1, 4. And the sign, therefore, is negative because 1 plus 4 is 5. And when you raise negative 1 to an odd power, you get a negative. Once I know the first one, since I've included all of my zeros, I can just alternate the signs. If I had left these zeros out, I might want to actually compute that negative 1 to a power for each one of these, for each one that I'm going to include. In other words, what I mean is, since each one of these is 0, then another way to write this is 1, that's coming from here, just the number 1, times a determinant that we're going to compute in a minute, times negative 1 to a power, where the power comes from the fact that this is in row 4, column 4. So this is the minor for 4, 4, and 4 plus 4 is 8. So I'm going to get negative 1 to the 8th power, which is a positive 1. So this is going to be equal to 1 times the minor of 4, 4. And the minor of 4, 4, 1 times, I don't need to write that 1. The minor of 4, 4 is, when I cross out row 4 and column 4, the matrix that's left over, or the entries that are left over, are these entries here. And the minor is just the determinant of those entries. 1, 2, 1, 3, 1, 0, 1, 2, 2, 1. So I want that determinant, and that will be my answer. I only need to work out one determinant in this case. To do that, I'm going to use this row right here because it's got the most zeros and the most ones in it. It's the one that's going to be the easiest to do the computations for. That determinant is equal to the coefficients. I'm going to leave the 0 off here just to make my point. The coefficients come from the non-zero entries. The signs are going to come either from the fact that this is in row 2, column 1. 2 plus 1 is 3. 3 is a negative number, is an odd number, so this is a negative cofactor. And this number 1, comes from this entry here, which is in row 2, column 3. 2 plus 3 is 5. 5 is odd. Negative 1 to an odd power is negative. So that's also going to be a negative cofactor. And then what goes in here is the minor, right? The determinant of everything that's left over. This entry came from row 2, column 1. Row 2, column 1. The determinant is the determinant of these 4 numbers here. 1 times 1 is 1. 3 times 2 is 6. I have 1 minus 6. That's negative 5. And then for the second one, I have, let's see, I crossed out row 2, column 3 to get to this one here, row 2, column 3. So I'm left with these values. 2 times 2 is 4. 1 times 2 is 2. 4 minus 2 is 2. So I get this. And that gives me 5 minus 2, which is 3. The determinant of this 4 by 4 matrix is 3. And I was able to figure that out just in this few lines here. Right? I had to really think very carefully about what I was doing at each step. The actual amount of work was relatively minor, no pun intended. All right, that's going to be it for this video, but I want to ask you to think about one last thing. What would you do if one of the entries, one of the rows or one of the columns in your matrix was made up of all zeros? How would you figure out what the determinant was then? Let's say you had a 5 by 5 matrix and the 4th row was all zeros. Since you can use any row or any column for your cofactors, what do you think the determinant of that matrix would be?